everyone. I'm Frances, and I'm so excited to be here and really honored to be among this group of speakers and these discussions today. I'm just really tickled to be part of it. I want to acknowledge the whole team behind this work that I'm speaking on behalf of. And I'm very excited today to talk to you about using natural language processing, or NLP, to evaluate user experiences with digital health tools. So a bit of background, it's very important with digital health tools to increase user engagement. Many of these tools are self-guided, so we want folks to use them more. In order to do that, we need to evaluate their experiences. What can we change to make it better? And in order to evaluate their experiences, we often use exit surveys and exit interviews. And as many of you might know, exit interviews, especially if they're semi-structured or longer, can involve a lot of complex information that we need to synthesize. And if we're able to effectively synthesize that information and then retrieve what we need from that information, then we can better promote treatment uptake and adherence with digital health tools, which is ultimately what we really want. So where does NLP come in? There are many ways you can use NLP, and I know there's even a similar discussion in one of the posters I saw today about a different way you can use it. So today I'll be talking specifically about topic modeling and sentiment analysis. And just with exit surveys and exit interviews, you can use NLP to corroborate the data that you're getting from exit surveys, talking your basic Likert scales. What did they like? Were they satisfied? And then you can also use it to retrieve meaningful information from exit interviews and corroborate more traditional thematic analysis or content analysis. So here is Call It a Night, which is the example we're going to be using today. I used with my team convergent mixed methods to evaluate user experiences and look at NLP in combination with more traditional methods. So Call It a Night, it's an RCT, CIAN for short, that had 120 participants. And if anyone here has ever done traditional qualitative analysis, that's a big sample to do with semi-structured interviews, much smaller than some of the billion size samples we're talking about today, but it's pretty big for qualitative analysis. So CIAN was a digital sleep intervention to reduce drinking in young adults. It was a 2-week intervention, and at 2 weeks, there were exit surveys and interviews to ask folks what their perspectives were. There were 3 conditions. CIAN, the main treatment, involved personalized feedback and tailored health coaching based on the data that came in from participants. So that includes active diary self-monitoring and passive monitoring via biosensors. And they also got some web advice from modules. And then the 2 controls, there was web advice only, and then there was web advice and active self-monitoring through the diaries, but no feedback. All participants wore biosensors, an ankle alcohol monitor, and a sleep watch monitor. So now we'll dive into some of the more traditional results we got in order to compare NLP. So exit survey results across conditions were generally positive. These are 5-point scales, so program satisfaction, helpfulness of interventions, feasibility, all relatively positive, except for the ankle biosensor was a little less positive, which you all might not be surprised about if you've had experiences with collecting data on these. The only difference is that CIAN treatment and the control that involved active self-monitoring had some higher reported effectiveness. And now let's look at what we got from the more traditional thematic analysis. So this is a visualization of themes. You'll see the blue themes are helpful things about the different modalities in the interventions, and the orange themes are unhelpful things. We were able to do this visualization with a post hoc non-metric multidimensional scaling analysis just to kind of visualize and map out clusters of themes here. And also using multivariate correlation, we could fit characteristics of participants onto the themes to see if they varied with those, including trial group. So the gray polygons you see here are the different trial groups. And I'll just hone in on some of the clusters so you can get an idea of what we got out of this more traditional method. On the left side of the figure, you can see here mostly control group participants, and more than the treatment group participants, they're saying positive things about the web-based advice modules and the biosensors increasing awareness. Not surprising. And then over on the right side, the treatment participants who received everything were more likely to say positive things about the feedback and the personalized coaching, and actually more likely to say negative things about the website or the biosensors independent of getting their data back. So now let's talk about NLP. How does it compare to what we find from more traditional methods? The first thing we did was topic modeling using latent Dirichlet allocation. There are lots of different ways to do topic modeling, and just to give context, all of the analyses for this were done in R with free packages that you can use. And if anyone's curious about which ones I used, please shoot me a question. So how LDA works is you're basically looking at probability. So you give it a set number of topics based on modeling and fit and parsimony. And in this case, 9 topics. And it decides what the likelihood of words occurring in those topics are based on their co-occurrence in documents or interviews. And then it determines which topic is most likely to characterize your documents, like the interviews. So you can see here, among the 9 topics, these are the 10 most common words in their stemmed form. So that's why some of them look a little bit different. And also you can see how many people had interviews that were characterized most by that topic. So how did this converge with what we found from the more traditional methods? First off, we got a lot of the same themes, but in a different combination. So things that were helpful, like more awareness, liking feedback or web-based advice, depending on what you got, trying health tips, and also interest in different factors that affect sleep. And then the fact that these topics didn't vary by trial condition really converged or confirmed the exit survey results that everyone kind of liked what they got, but also had some challenges with biosensors, especially the ankle monitor. And there was even some added insight in this method into topics that didn't come out in the thematic analysis. As you can see, the green topic there, changing poor sleep, that people were drawn to the study because their sleep was really a problem for them. And then the sentiment analysis. So for this, we used the AFIN lexicon. A lot of folks may be familiar with this, but there's a bunch out there. This takes a set of words that are already predetermined. They've been ranked from negative to positive on -3 to +3. So every document gets sort of a net score from all the words it contained that were rated. And so 0 would be neutral. So if your interview was 0, it means you liked the intervention as much as didn't like it. So that gives context to our mean score here of 15, meaning that people generally liked the intervention in a range of -16 to 47. So we felt that this confirmed the exit survey results in particular, which might be more subject to response bias, people saying they generally agreed, but wouldn't be subject to that when people are speaking in an open-ended way about their opinions. So what are the implications of this example when you're comparing NLP to more traditional methods to look at user experiences with digital health tools? NLP can be used to quickly model topics and sentiment across a large subset of exit interviews. And this can be scaled up to a very large size. As many of you are probably familiar with, LDA and other methods are often used to model topics in millions of posts online is a common application. So it can be scaled up for sure, past the point where it's practical for people to do traditional thematic analysis. It can be used to corroborate quantitative survey results, as you saw here, corroborate or even replace qualitative interview results, depending on your project needs and your team availability. And just to dive in a little closer on NLP versus thematic analysis, there are definite pros. It's faster. It might be less influenced by researcher bias on the front end, whereas you're creating the coding framework yourselves in thematic analysis. the machine learning gives you the framework based on co-occurrence, and then you interpret and name the topics. And then also it might be more generalizable. Often with traditional thematic analysis, generalizability isn't the main goal, but you might have that as a goal if you have a large sample, you're testing an intervention, and you're looking at word co-occurrence. And then the cons are that with NLP, you definitely might get less specific results, especially differentiated results, than if you're doing a highly detailed, nuanced thematic analysis. Like you might have noticed there was more differentiation by trial group when we really broke it down in detail. So NLP might be more efficient, but sometimes less specific, depending on your questions. So that's a short snapshot of this example. I want to thank everyone for listening. And please, if you'd like more information after today, reach out, especially about packages used or anything else. And I'm excited to take your questions today. But also, before we start that, I want to acknowledge the NIAAA that funded this RCT. Thank you.
Yeah, thank you so much. We have time for questions. Yeah, please go ahead.
Thank you so much. I was wondering how efficient or how accurate is, can you use this as a depression screening and prediction based on just the words from the exit interview?
Did you say how accurate is it if you're just using it based on the words in the exit interview? That's a good question. So I'm thinking especially about sentiment. You all might know that we often use phrases like "it was not too bad," or context gives a lot of clues. So I think it's important that there is, and this is just my opinion, that there's kind of a back-end human at this point who's looking at the topics, kind of reading a sample of them if possible. And you can also feed specific phrases, kind of teach your model about things that it hasn't gotten right, like that, like maybe a multi-word phrase. And so I think that's kind of part of the iterative process that may sometimes take a little longer, is to see how right it was in kind of grouping things.
The reason I ask that is sometimes in certain cultures, people say things, but they don't really mean what they say.
That's definitely true. Yeah, I think that's part of the nuance or detail that could be lost. I've even had experience with doing larger data set analysis of posts online, and you might get something grouped with something else, but maybe it was written actually by a chat bot, and you might not be able to filter out what's actually the data that you want based on just the language that's being used. And so I think that's all part of enhancing the model, which I know some other talks here will talk about more, and also just checking how things have been categorized if you're speaking specifically about exit interviews.
Is it possible to use the intonation from the voice recordings?
That's a good question. We actually are using intonation from voice recordings in another study coming up, which you could do. I think in this case, in this study, we were looking more just at the text, but that's absolutely something you could incorporate. I think, are you implying kind of like if you're talking about valence or emotional tone, that you could have that as something to layer on information, whether someone was being positive or sarcastic?
Yes.
I think that's an excellent idea. Yeah.
Thank you.
Yeah, thank you.